I'll hand it over to you.
Thank you very much. If I can just bear with me a second while I work out how I'm sharing screens.
Okay.
You should be able to see my screen coming up now.
Yeah, it looks good.
It'll be black, so it'll probably confuse you. So thank you for the introduction. It's really good to be here. I haven't done one of these in a while, so it's exciting, but nerve-wracking at the same time. Yeah, I do a lot of things. I'm a digital railway guy, and I'm the lead integration specialist for control systems and signaling. But tonight I'm just a system engineer, which is really all we are, if we're all being honest. I'm not claiming to be an expert in everything or to know everything, but I am a conscious observer of what we're doing and the railway, and I've been around it for a little while. So yeah, this is my view. I've been doing this for about nearly 15 years, and like I said, I've worked on a variety of things, from being one of those guys out in the rain and the freezing cold, testing circuits and fuses and making sure things still worked, up to defining final solutions. And it's been interesting, and there's a lot of challenges that appear very similarly, whatever level you seem to be sitting at, which is somewhat comforting, and that you know us to solve them, but it's also a little bit annoying that we haven't solved them already. So tonight, this is all about system engineering and Brunel managing without it. Now, the railway has always been complicated. We all know that. Building railways has always been a complicated task. But the scale of the projects we're taking on, in part driven by the pace of change, in part driven by the demands of obsolescence and the demand of COVID and other things, means building railways is a greater challenge than ever before. So in this talk, I'm going to cover that additional complexity of what it means, and just kind of show why the traditional approach doesn't really work anymore, and what I think we need to do to solve it. Now, you're probably wondering, some of you will be wondering who Brunel was, right? If you're not in the UK, Brunel probably doesn't mean anything to you. So, Brunel isn't Brunel Brunel. He was one of the pioneers of the railway in the UK, very much a visionary. He built the Great Western Railway, which was the railway line that ran all the way from London down through Bristol, down through the southwest of the country. He pioneered a lot of the techniques that we still use. A lot of his bridges and formation areas are still there, stuff that will last for quite a long time. It's some of the bits that actually do last and work. He was also quite visionary. He felt that the railway shouldn't stop at the coast, right? He thought it should go all the way to the US. So when he finished building railways, he built 3 ships. He started off, he built the SS Great Western, which is a wooden paddle steamer, a transatlantic passenger ship. When it came down the ramp, it was the largest in the world. It set the records for the highest speed and fastest crossing. Then he built a few years later, he built the SS Great Britain, which was the first propeller-driven ocean-going iron ship, which was again the largest ship ever built when it went to sea. And then he built the SS Great Eastern, which shipped out just after he'd passed away, actually. And it was iron, it was sail-powered, paddle steamed, and screw propelled. It was the largest ship ever built, 211 meters, 692 feet long. And then it was, after it served its time as a transatlantic ocean liner, it converted into being a cable laying ship and ran some of the first transatlantic cables. So he's quite a visionary. Why am I talking about Brunel? Well, he started building railways quite a long time ago, about 150 years. And the railway has moved on quite a long way in that time. But it doesn't seem like anybody's noticed, right? So the railway of 1843 essentially comes into 2 parts. Right? I've omitted rolling stock, but essentially it's a mechanical system. You've got civil systems and you've got mechanical systems. There's no electrical, no computers. Fundamentally, it's these 2 things. And the thing is, structures drive mentality, right? So civil and mechanical, very much on the same spectrum. One is a heavy version of the other. They probably won't appreciate me saying that, but fundamentally that's what it is, right? So it's easy for an engineer to cross disciplines. They make use of the same physics, right? They're subtly different, but they're on the spectrum, right? They're on the same spectrum. If you sit at one end, you can kind of work out what the other guy's doing. Structures are big civil structures, mechanical structures. You can still work out what they do. The tools essentially were pens, papers, and drawing boards, plumb lines, and bits of chain. I mean, it's simple. Don't by any means mistake simplicity for lack of sophistication, because it was still very sophisticated, but it was a simple concept, right? Conceptually quite simple, and your engineers were all very much on the same page. So the level of integration you required, the level of control of that level, the way you did control that integration was very different. You had engineers who all understood what they were looking at. Now the problem is that complexity has increased in order of magnitude since we started doing that. It's increased in a number of different ways. First sort of principle, one of the most notable, is scale. Right, 2021, it's scale. If you've ever worked on a mega project, HS2 came up earlier. If you ever worked on one, you know that just keeping track of people and roles remits is nigh on impossible. Having a working org chart that doesn't change every 30 seconds is magic. As close to magic as you're going to get. But the scale of these things has changed. We've got civils and mechanical still there, but now we've got this electrical discipline, and that didn't exist before. But now we've got it. But the thing is, we haven't just replaced other stuff. It's there as well. You'll notice there's a box in the middle, a little dotted line around it. That's mechanical signaling, right? Mechanical signaling and mechanical point machines. They're still there. We haven't got rid of the mechanical signaling. The guy in boxes pulling levers, he still exists. Right? We still run it. Yeah, it's a smaller part of the network, but he's still there. And we've got to integrate with that. All right. There was a project a few years back now on Salisbury Exeter where they had a computer, they were putting in a computer controlled signaling system. And the next box over was a guy pulling levers. He had an absolute block machine, right, which is like an oak and brass bell that tells you when a train's about to arrive. And to integrate with it, they had to put an oak and brass button on the desk of the computer system in the new control center to integrate with this absolute block system, because it's heritage and you can't get rid of it. The scale it's the scale, and the fact that nothing has changed there's loads of old stuff still there, right? And that we've picked up all sorts of stuff. We've got solid state interlockings, we've got computer-based systems, we've got control systems, we've got planning and modeling tools, we've got smart ticketing now that never existed and is like just kind of coming in, we've got traction power and all sorts of other stuff in there. But this is only half the story, because whereas volume scales linearly, complexity scales exponentially, right? Interconnectedness is that challenge, right? And you can see, I mean, you look at some of the boxes, you'll see some of the dark blue boxes have now migrated across. There are some boxes that duplicate. We've got tunnel vent systems across all three, because they're mechanical systems that are driven by electricity, controlled by computers, but sitting in the civil environment. We've now got integration across all three disciplines. You know, we've still got the mechanical signaling in there, but now it's driven by a computer somewhere instead of a man pulling a lever. It's got pneumatic actuators, which never had originally. This is all being retrofitted on board. When we factor in that scale and complexity for each team, the more people are in the loop, the more workflows you have running in real time, in parallel, the more complex and complicated that system becomes. Right. And you just look at it. I mean, rolling stock is now on here, right? You can't. The top of the middle row in the electrical box is onboard control systems. The train is now part of the signaling system. It's half the signaling system. In fact, it's a counterbot system. Half sits on the track side, half of it sits on the train now. That didn't exist before. Right? That whole electrical paradigm has arrived, which never existed. Right? The subsets of electrical are computer-based, right? That means software. It's taking place now inside a black box that is not visible to the outsider and is largely unintelligible to non-software engineers. And they're not even. I mean, electrical's not even on the same spectrum as civil mechanical, right? Civil mechanical is big macro stuff. Electrical's not even using the same physics anymore, right? Software's not even using physics at all. It's just a made-up language. And somehow our engineers have got to be able to bring all this together and understand what that complexity actually means. Right? All these systems now interact. Right? They create behaviors, some of them beneficial, some of them not, some of them expected, some of them understood, some of them emergent and quite confusing. Silos exist that didn't exist before. And the killer thing is that certainly in the UK, we design our railways, we design our kit that goes on the railways to have a 30-year life expectancy. So we don't, once it goes in, we don't touch it for 30 years. Some of it we do a midlife upgrade. Most of the time, we don't touch it for 30 years, which means there are engineers out there. Because of that long life, there are engineers out there, civil and mechanical or electrical, who've never had to work with another discipline. There are mechanical engineers who've built excellent mechanical stuff, never had to work with the electrical guys. Electrical guys never had to work with the signaling guys. Signaling never had to work with anybody else and didn't really want to. And the scale, I mean, just think about the scale of the transformation, and what that means. The old paradigm of an engineer who just knew his discipline, who just did his thing, or her thing, it wasn't usually his thing in fairness, who did his thing, who designed stuff and then just passed it out and didn't really care about what happened to it after that, that's gone. This is now, everything we do is a transformation program, in effect, because of the scale and the complexity of it. It's essentially transformation. Without system engineering, it's essentially uncontrolled, right? Because it's people, I mean, everybody's doing their thing, but no one's controlling the whole picture. Just stop there. I mean, I have a tool slide now. I didn't even need a slide when I was talking about the 1843 model because things were quite simple. But now we have to have that. Now we have to do this. We have to recognize the fact we have this tools landscape that didn't exist. In 1843, everything was drawn by hand by draftsmen to an engineer's calculations. In 2021, every engineer is a draftsman, or to a degree. Proliferation of CAD tools is seen to that. But more than that, every discipline has its own tools. Every engineer has access to multiple tool sets, plus the coordinating tool sets of things like doors and requirements management tools and other things. We've got emails and other multiple comms methods. We've got multiple engineering management systems. We've got multiple design systems, simulation tools, GIS modeling, BIM systems, CAD systems. And that means multiple sources of truth. You've got a small enough project, that's not necessarily a problem, but you scale that up to something like HS2, where you're 100 miles across from one end to the other, and thousands of people and tens of thousands of or millions of assets and tens of thousands of work packages over its life, over 30 years. That's an awful lot of information. We've not even got to the automated stuff yet. Automate design packages, automate test systems, in the loop testing, hardware, real hardware, software, firmware, that kind of stuff wasn't done in the same way. That's completely changed. Don't even get me started on things like digital twins. I mean, we've got common data environments and all the tools that go with it, and that's fundamentally changing the way. It's fundamentally changing the way we interact with data, right? And how data influences our decision making. Like it or not, and there are many who don't believe this, and half my job is explain to them that they have, is that we've built a system of systems just to deliver a system of systems. We need system engineers to manage the tool sets just to enable us to do system engineering now. That's how complicated it's become. And going hand in hand with that, one of the things, the fundamental change that I don't think anybody's, in a lot of sense, people haven't really realized is that 1843, all the control rested with the chief engineer. They were the project director as well as being the lead technician, but not anymore. Now the delivery is controlled by the PMO. It's controlled by project directors. The engineer doesn't have complete control anymore, which means you've got potentially multiple competing agendas, different politics at play, and that in itself requires a different paradigm of stakeholder management that we never had to do. Contractual management, we were talking before, contractual management, right? The contractual management side of it is now far more complicated. One of my jobs, or used to be up until a few months ago, was actually helping draft some of those HS2 contracts, some of the technical elements of those contracts, and the complexity and the the interaction between the contracts and the contractors. It is much more sophisticated than things, certainly than I've ever worked on. 15 years of doing this, and the railway, the projects were never this sophisticated. They've got more and more so, even over the last 15 years. much more complicated. And I think some of that is because we're seeing all this paradigm, all these changes, but I think also because we didn't know how much complexity, we'd never tried to map it, and we didn't realize, and now we're seeing it. It's how we've got to address that. So just as a summary, technical complexity has increased, right? It's massively increased. The pace of change has accelerated. The pace of delivery has increased. We're doing all this on brownfield sites now. Brunel, he built greenfield railways. He didn't have to worry about trying to keep the trains running or the passengers happy, right? He never had to worry about stuff like that. We do. Stop a train. Passengers, they don't care that there's a really complicated system being built. They don't care that it's the most sophisticated system in history. All they care about is their trains are 2-3 minutes delayed. We've got to account for that now. We never had to before. We do now. We're flying a far more complicated, far more ungainly program, and we've got to land it on a much tighter target than has ever been tried in history. And I just imagine that I'm almost talking about it as if it's one program, but it's not, right? We've got multiple projects per program. We've got multiple programs per company, per country, per portfolio, multiple running in parallel, right? We're not even, and that's just, you just look at the whole industry, not just the UK, look at it around the world, and the similar things, similar shifts are happening. The question is, how do we go about solving that problem? So I think naturally, I think system engineering is the answer, but I think we've got 3 challenges, and I think there's 3 challenges I think we need to overcome. And I think as system engineers, it is incumbent upon us to try and solve these problems, because we're the only ones who understand what's meant to happen. But we need to help other people to understand as well. The 3 challenges are the challenge of understanding, the challenge of misuse, and the challenge of resources. Understanding is essentially put that people don't understand what system engineering does, right? They think it's too specialist. They think it's a small body of professional system engineers. They don't see it as a toolkit, right? They don't see it as a toolkit to solve problems. They see it as a discipline in its own right that has to be siloed, like every other discipline that operates in a silo. They don't appreciate that actually that's not the way it works. There's too much assurance. They see it as too mumuch assurance. They don't understand that actually, if system engineering is applied early, it's about unlocking potential and unlocking innovation. And they think there's a misunderstanding that it drives the wrong outputs. People expect system engineering to be that golden bullet and it solves everything. And actually, it's that basic shit in, shit out problem that if you don't feed it the right information, you don't get the right answers. So we need to help people. We need to educate and keep on at this, because it's quite a big challenge, a big hurdle to get over. If we can get over this one, and we are starting to do it, we then have the challenge. Firstly, is that system engineering is seen as being too slow. It's brought in late. It lags behind project delivery. We need to integrate that. We need to integrate that idea of system engineering being day one. You start by doing this. You start by making sure that you assure your program 10 years out, rather than bring it in late. There's that problem. People think it's a process driving thing. And I think in some respects, system engineers are just as guilty as this. We've got a lot of system engineers who are process drivers. Right? There are a lot of, certainly in the UK rail industry, you'll find there's a lot of requirements engineers who are system engineers, but really they're just requirements engineers, and they solely do requirements. We need to make sure that people understand that that's not what we do. We're not process drivers. We're problem solvers. We're just using a process that helps us solve that problem. We also need to make sure that our system engineers have that domain knowledge. I think that's one of the things that I've seen repeatedly in the rail sectors. We get a lot of really good system engineers, and we're bringing them in, which is a really positive step. But they're coming in from aerospace, or they're coming in from defense, and they don't have the domain knowledge to engage the teams quickly and build the rapport, which is what you need for these things to be fully integrated. So I think we need to solve that problem somehow. It's seen as being very tools heavy and used as a very heavy, either seen as being very heavy, and therefore we don't want to introduce all of it. I think we need to solve that problem, get people understanding it's a process. Tools are just part of the job. You don't have to buy the full IBM Rational suite to manage requirements. You can do it other ways. It's just the process that matters. And people believe it's very much an all or nothing. They don't understand that you don't need everything. It's a scalable tool. We can make it fit for whatever the problem is. We just need to know, and you just need to be flexible about it enough to understand that we can do it, and you just got to work with us. If we get through that, we've got this issue of not quite having the right amount of resources to do it properly. At this point, you're probably feeling a bit like Groundhog Day. We've had this conversation before. Well, that's because we have had it before. We've had this conversation time and again, but we still don't have people bought into it. But we are getting closer. I think with every conversation we get a step closer. With every extra person we talk to, we get one more person who goes, "Oh shit, that's going to affect me. That's going to cause a problem for me." On the positive step, we have seen larger numbers of system engineers entering the industry. That is really positive, but we need to make sure they're used wisely. So how do we go about solving? I think the solutions have got to be as multifaceted as the challenges. I think we've got three ways of looking at this: short, medium, and long term. In the short term, we've got to harness what we've got. We've got a better education, and we've got to go build it. The short-term thing is a short-term solution that we've got to draw on our systems thinkers. Right? If you look at the demands of system engineering, it can be basically summed up as understanding the system end to end. Right? Now, on a project, who is it that actually has that knowledge? Who is it that has that knowledge and on the ground understanding to be able to interpret what they need to deliver and how it should behave and understand how it fits in? The answer is the project engineers and testers. Project engineering is about drawing together all the technical aspects of projects. I assume everybody has project engineers. If you don't, a project engineer in the UK is the lead engineer that oversees everything. Sometimes they've got a project engineering manager. Sometimes they're a lead project engineer or principal project engineer. They are the engineer that oversees the integration delivery. They cover off design. They sit over the installation, the testing, the engineering management, resources, procurement, logistics, access, all of it. Testing, specifically the functional and principles testing, which is about proving the system end to end. Really, principles testing is about proving the system works end to end. For that, you've got to understand how it's designed, which means you've got to understand what it's meant to do in the first place. So your test engineers actually sit across quite a lot of the technical detail. So they could also be used in that way, right? We can also use both these pools of people as system engineers. We don't, but we could. I believe this is an untapped resource, right? As you might imagine. They have that practical experience of hands-on delivery and the end-to-end areas, the end-to-end view. And we've got readily upgradable community of people here. Right? And yeah, okay, it's going to leave a bit of a deficit in the project engineering test environment, but actually we can secondary skill designers to alleviate some of that. We have done in the past. I mean, the rail, it's changed a lot now, but in the, even when I started, all designers were expected to be secondary skilled as testers or project engineers. So they didn't just do design, they could do other things as well. We can still do that. We can still bring that level of integration by dual skilling people and bridging that gap until we've got a longer term solution. In the medium term, now if you read any of my stuff, we'll see it. Or you may have picked up from that. I think all engineers should be systems thinkers. I think we should all apply system engineering. It's just a tool, right? So the railway has a shortage, but we can rectify it by training our existing community. That could be the project managers. We already talked about project engineers and test, but designers, installers, it can all be applied, right? And the good thing about system engineering is it's quite modular. We can teach it in modules. We can start with user concepts for some and requirements and verification for others, system architectures or whatever we choose, and we can add and expand capability in a modular way. We've had we've had some of that going on. Design starting to get requirements and stuff. but we need to propagate, right? We need to spread out throughout the team. I think it's something we've got to start doing now. If you look at the volume of change, and I apologize for not talking too much about the global market. There's a lot of change going on in the UK at the moment that's taking a lot of my attention, but we're changing our entire rail model. We're getting rid of franchising largely. We're putting the INCOSE taking on a lot more risk, a lot more ownership. We're getting rid of the existing infrastructure, the existing companies, and changing them. We're cutting bits off HS2 and adding new bits on. We're talking about upgrading all sorts of different bits of line now. The volume of change on those programs is huge, right? I don't think that what we've got in the industry at the moment in terms of resource and capability is going to be enough. Right? It's not going to be enough to cover off all that. We have a shortage, and we need to rectify it urgently if we're going to be successful. And ultimately, we've got to remember we're delivering for the passenger, right, the end user. There's a tendency to look at engineering for the sake of engineering, but we're here to deliver something for people trying to go to work or go and see their grandkids or whatever. We're the backbone of the country in some respects. We need to be thinking about how we solve this problem. In the longer term, I think we've got to start training graduates and apprentices to do this, right? All engineers should be taught this, I think, and I passionately believe they should all be taught system engineering. It's bold. I appreciate that. Not everybody agrees. I've had many people tell me it's the wrong way to do it, but I disagree with you. I think if we teach it as a tool, we teach it as a practice, it becomes the norm, right? People start using it every day. They practice it to the point of becoming efficient. We don't have this resource issue. System engineering becomes the way we deliver things. Doesn't matter the scale, we scale it instinctively, we deliver it instinctively. It becomes the way we do things. The discipline itself will then evolve faster. It'll become more responsive to the needs of industry, not just ours, but any industry. It'll make the whole of this much, much easier. And I'm a great believer in practicing what you preach. I'm a visiting lecturer at Birmingham City University, and we've just overhauled one of our project delivery modules, and we're delivering it using a lightweight system engineering methodology. We haven't told them that's what it's called. We just told them it's an industrial process, but it is essentially using system engineering to help them deliver their projects. That's live now. I'll let you know how it turns out. But at the moment, it looks like it's going. It looks like it's being taken up well. At that point, I would normally write a closing statement here, some pithy line. I tried when I was writing this, but I think actually it's really a case of what do we want to choose to do next? Where are we? Where are we going? What are we going to do? There's plenty of opportunities out there. There's plenty of demand for what we do. It's just it's a question of us picking a lane, committing to it. With that, I think I'll open it to questions and so have a proper conversation. Thank you for listening.
Thank you, Tim. Very good. Are there any questions out there on the chat line? I think we have 14 people signed in today for the presentation.
Yeah, hi, it's Dale. I had a question about the just the last bit on the it sounds like a tailored approach. Is it possible for you to go into any level of depth on that tailored approach that you had mentioned? I think you called it a sort of a lightweight version.
Yeah. So what we did is, if you take a standard academic project, so it starts with a bit of a literature review, and then you go through some research, and you write your methodology and so on, do your research and evaluation. We've shaped that slightly differently. So the literature review is very much a technological and a methodological study to understand what your solutions are, come up with option selection, same things for methodology, with the output being that you define your system, right? So you end up writing a system definition. You create your logical and physical architecture diagrams as part of that. Write a very lightweight requirement set, but a requirement set that you can then later on, instead of doing like your standard evaluation stuff, you actually go back and write V&V statements against. we've kind of got that loop of doing proper V&V. Like I say, it's lightweight, and we're trialing it. So we'll see what happens.
Okay, thank you. Yeah, because one of the observations that at least I've had over the years is that, well, I can give you an example of a project I'm involved in now where it's supposed to be a design build, as they call it. That's the contract language.
Mhm.
And yet we're going to close in on, I think, on the order of 30,000 requirements, of which at least a third of those 10,000 were issued at RFP. And it just kind of leaves you scratching your head. Well, if this thing was 85% out of the box, as it were, or off the shelf, why did it take another 6 or 8 or 10,000 requirements to define a fairly, as I say, out of the box train control system? So that's kind of one of the observations that we've been having. So the lightweight might be actually, it's going to sound like corporate speak, but right-sized.
Yeah.
You're giving sufficient detail at the system level to define, to cover the user needs.
Yes.
For all the stakeholders, without being the role of the frustrated designer that, oh, gee, I've always wanted to design a train control system as I'm writing the RFP documents. Why don't I just go ahead and do half of it for them? Yeah.
That is a pretty standard problem I found, certainly with the more complicated, more advanced systems. You tend to find people write thousands and thousands of requirements. And you're like, Jesus, you've designed it for me. Why are you paying me again?
Yeah, but I think California High Speed Rail's done the same with their tracking systems RFP, because it's clearly written, I think, and I know the guys who did it. It was, oh crikey, something's happened somewhere in the world. Oh, we better put something in to cover that. Yeah. So we've got sections where it just says to do this, and other sections where it says, install me a blue wire, and it's like,
yeah. we still have the same things. I got a contract once where we were talking about axle counters, and there was stating things called Tollerton controls, which you only ever use for really short track circuit sections because they bob. You can't get that with axle counters. You don't. Where did you come up from? You clearly cut and paste that from somebody else, not understood what you specified. Solving problems you don't need to.
Tim, you've got there the future. That's the slide we've ended on. And I think I completely agree with all of your problem statements around how one sells systems engineering. I'm almost going to be controversial. Do you think we need to lose the title systems engineering and actually just make it in the same way that you had at the beginning, civil engineering, mechanical, and all of the processes that those people follow, design or whatever, they're just processes within their discipline. Do you think actually systems engineering itself trying to come in and say to those other disciplines, you're doing it wrong, we can put these processes in place, is actually alienating more, and we would be better off almost killing our own discipline to just insert it into others?
I think ultimately that's got to be the objective. I think if we're training if we're training people from the ground up, that's what will happen. I think that's, for me, that's the end goal. I think system engineering is a tool, a very sophisticated one, but it's still a tool. Whether it alienates people, I think to a degree. I think it depends where you go. I think you talk to the control systems people, talk to the telecoms people, and they get it. Go talk to the civil engineers, and it's a different conversation entirely. It's just not how they build things. They've been building bridges for 5,000 years the same way. Why change? I think there has to be a case for saying, how do we tailor it to fit better into what their view of the world is.
Yeah, there was a kind of along the lines of this last thread of thought. John Thomas, I think he was the former INCOSE president, and I remember in one of his closing farewell speech type thing at IS, he said that, and I think he's really addressing the whole MBSE thing, which became it almost created a schism within INCOSE where you are either an MBSE or something else, something lesser. But he just kind of wanted to bring everybody back to ground and say, remember all this systems engineering stuff, we used to actually just call it good engineering. Where the engineers were sort of trained out of the box, if you were, professionally as holistic thinkers.
Yeah.
Another comment too, which I found I totally aligned with, was the test engineering bit. I've done sort of an informal survey of folks that I've interviewed for various jobs, and I do find some of the better system thinkers and better systems engineering candidates came from a QA test or V&V type background.
Yeah.
So I sort of agree with that quite a bit, actually. Because you're often forced, I came up through that way, you're often forced. I think my first realization before I even met the word INCOSE, just going back a few years, was that, gee, wouldn't it be nice if the mechanical and the electrical guys on the locomotive talked to each other someday before they sent this thing out to the final test shed?
Yeah.
Of course, I was living out in the final test shed trying to make it all work. And then somebody said, well, there is this thing called systems engineering that, that kind of covers that. Oh, okay, well, that's cool. And that was my introduction to INCOSE, but as a younger person. But that was my experience in life, that, oh, okay, if engineers are not collaborating and getting out of their silos as frequently as they should, then you're going to end up with stuff that doesn't work.
Yeah, completely.
Like the conference system in the room we're all in right now. Sorry, I'm just so irritated by it. I had planned for this, coming to San Francisco and having a group in this room for like a month, and just, you expect it to work, right? Somebody didn't talk to somebody when they put this room together.
User requirements.
Yeah.
Tim, I've got a question for you, or a thing to think about, really, because as you started your presentation, railways were basically a civils and mechanical engineering kind of problem. And you had the thing that built the infrastructure so you could lay the tracks, so you can add stations, and you had the thing that made the engines and the trains to ride on the tracks. And then we had the electrical environment. So we have electrical power and electrical kind of solutions. Now we have digital issues, and we've got other aspects of technology which requires their own type of engineering. So as more things have added, we are in a situation where there needs to be some group that needs to be the multidisciplinary person that helps the others decide where do they play. And is this an engineer, is this a mechanical problem, an electrical problem, a civil one, or one we need to sort out before we figure what's the right division between those single disciplines? Where have you seen that in your current processes around dealing with the multidisciplinary environment?
It's a constant source of pain.
That's
Getting people
our bread and butter.
It is. Yeah, no, it's like you say, it's what we do. Before I did any system engineering, I was a project engineer, and we still had the same arguments. Who's going to go build the signal base? Who's going to go build the put the gantries in? It's a mechanical problem or a stations problem. Or actually, no, we all have to be here. It all has to work. So I think, there's definitely a case for having people trained as interdisciplinary engineers, I think. And I think system engineering is the process, the tool that wraps around it. But people with a broader knowledge, a lot of people, most engineering degrees are a single subject. They specialize. Getting them to open up and step out of their little box that they've been trained into for 4 years is a challenge in itself.
And you do need people of both flavors, where you've got those who are looking at the bigger picture and those who are very specialized and do what they do very, very well.
Completely. Yeah.
Yeah.
We need the experts. You just need to get them to work together.
I think
That's
one problem with the narrowness of the education is in the accreditation system, where in the accreditation system, certain discipline areas are so focused on how they interpret their discipline area to be that they don't include the systemic view of what's it all for. And a consequence of that is that people come out of those degrees, which have all been shaped by that particular perspective, thinking of their favorite technology being what engineering is, and actually forgetting that the engineering is about solving a problem in society.
Yes. Yeah, very much. I think in some ways, universities are training PhD. It's an extended interviews for process for PhDs, isn't it? Right. It's training
There is an
academics.
element of that. Yeah, I'm an academic. You may have known that. There certainly is an element of that, and I have some concerns about that from an ethical point of view of, a PhD is not for everyone. If you've got the personality where you should do one, then you absolutely should. But if you don't, get on and do something else with your life, and you'll enjoy your life more.
Completely. And we need different types of engineers. Research requires a different skill set to going out and building things.
Oh yes, yeah, they are different. And then there's these things which relate to specific technologies. That's essential knowledge to get the depth of dive into certain things. But there's also a need for everyone to have an appreciation that they're contributing to a bigger whole that they don't have the detailed technical knowledge to deal with.
Yeah. Yeah, I think that is definitely lacking.
And I think rather than pointing it purely at the universities, there also needs to be some sort of persuasion of the professional societies who are doing the accrediting to shape their view of what engineering is. Yeah,
I think it needs to be, there needs to be a little bit of rigor around it, I think. I mean, your mechanical, so I've got a bit of experience with the IMechE and the IET, and so the IMechE is quite rigorous. It's got a clear view of what they're doing. The IET is kind of where we're just engineering technology, so it's quite broad. But it's almost uncontrolled in some respects, because anything's engineering technology. I could fit anything in there. Everything from railways, nuclear power. I could go make widgets in a factory somewhere and still fit under the same banner. It's how you bring it all together, and that realization that some of this process stuff actually fits everywhere, and some of it's quite unique.
And I saw a bit of that when we had both IET and IMechE doing a single accreditation visit for our degree. It was an interesting experience.
I can imagine.
Okay, any other questions? I notice we've got a few other joiners.
I guess as an extension to this, I talked a lot about the technical complexity of programs and how that's increased significantly. Another thing, I'm not sure if it's just a different experience here in the US, but it's the contractual complexity of how packages are put together. And I'm wondering if you thought much about that. Like, for example, the program that we're working on over here with Dale, we're working on a train control system, but to achieve the agency's overall goals, there's also a vehicle procurement. There are extensions going on. And I don't think there's a holistic view at the agency of how these all come together to actually achieve their end goal.
Yeah, I think that's quite common. So on HS2, we've got a team called the capability team that is focused on actually making sure we've specified the outcomes across all the disciplines. I actually helped set that team up. I worked on it for about 18 months. And the job of the team was to, what we were doing was going across all the packages, all the disciplines, finding out what their interfaces were, finding out what their interactions were going to be, and what their interdependencies were, making sure we made sure that was contracted, it was captured, we had it in the architecture diagrams, we had the interface registered, it was all, made sure that we knew what the outcome was going to look like, and that it was reflected in the contract, because otherwise it's just, like I say, it becomes very messy very quickly.
Yeah, that would be a welcomed development over here for sure. You got rail car procurement that has brakes and traction motors that aren't adequate to meet their train control goals.
Yeah.
Yep. I think some of these contractual problems have their analogy with the problem that systems engineering has of you spent all this time thinking about the project, but what have you built? And the
Yes.
value of systems engineering. And I think there's probably a tendency in the contracting to say, I have to let out all these contracts to people to do this, that, and the other thing. But the problem is that to let out a contract, you've got to specify what the thing is, what the deliverable is, and then you have a problem that you haven't necessarily got the most appropriate interface between the various aspects.
Yeah.
Whereas if you did more of the design at the whole system level and then created the contracts, it might be a better order to do things. But it means you need the ability to do the central design in the central principal organization.
Yes, yeah, agreed. And it's not just for make sure your contracts, but as you build things, they return as built design and real products at different rates and across different packages. And you've got to make sure that you incorporate that data. You've got your real as-built next to your virtual design that hasn't been constructed yet, and making sure that they're cognizant of each other, which you need that central understanding to be able to force that integration.
Yeah.
Paul, good to see you there. I remember you gave your presentation this summer, I believe, and
Yes,
it was
sir.
quite well received. I would just like to add a comment on the contracting. Contracting's can be quite complex, but if there's not a good contract change process, it becomes very difficult to do these issues. And if it's not very risk-based to help manage these issues that come up that are risks against the contract not being fulfilled, and the collaboration that's the two parties on that contract have to still deal with problems, yet not fight over who's liable. I guess there's ways that could work, but it all depends what kind of contract you have. Comments?
Yeah, just a strategy thought, at least for sort of the APTA and INCOSE effort going forward in that area, is that we're thinking very seriously about going out and working with the procurement and legal arms of the or divisions of each of the large transit agencies, whoever will listen to us, and sort of try to open their eyes a little bit and expose them to holistic thinking. We would have to literally be using those kinds of terminologies, because you'll be speaking to entirely non-technical folks. A lot of them will be lawyers, some of them will be politicians, and sort of get their try to secure a little bit of buy-in to be open to even do things like early supplier engagement, where you do a subset of the project. We did this for a portion of the Jubilee Northern Upgrade project, where we looked at the train operator display, and we had 3 companies come in and with the same set of requirements. And part of the bidding process, which was a little unusual at the time, was they actually had to build something. They didn't build the whole thing, but they had to build a working partial prototype, and they got paid to do it. But it sort of gave us a whole new approach to evaluating teams, because we could evaluate how what they were actually like to work with. We could evaluate that whether their processes that they claimed they were following. You know how in contracts now, the first thing that happens is you ask these companies to, as you're sort of looking at their suitability to the project, oh, please produce the following 50 program plans for us. You know, the RMP, the SDMP, the QA plan, maintenance, you know, but we actually made them execute on a lot of those plans. And it told an interesting tale. So that's, I mean, that's one approach, is to just look at how feasible is it to change the model of going out and, you know, competitive bidding, keeping it fair. Because, you know, that's a big issue, especially in the US with the, you know, more extremely litigious society, shall we say. But I'm sure it's, you know, similar all around the world. You have to have fair competition, fair bidding practices. It's still try to do some early supplier engagement, get as much intel on the, especially if it's, you know, it's a, well, the one we're on is potentially a $2 billion job if you include the vehicles. It's a lot of taxpayer money. That's a huge fiducial responsibility to the traveling public. So anyway, I'll stop rambling, but that was just that's one thought we have going forward with the APTA and INCOSE efforts for 2022, is to kind of maybe look at that avenue of just how are these contracts created, who's writing them. We have to stop the same as last time, except just cut and paste. I can't remember who said it, but you know, the definition of insanity. You know, if you keep doing the same bloody thing, you're going to keep getting the same results that you're not happy with.
I think, as Tim mentioned more concisely in his presentation, was shit in, shit out.
Yeah.
Yeah, exactly.
But on the question of kinds of contract, something that I've noticed as an academic is academics produce a service, education. The university I worked in Australia had a contract with the Australian DOD for education. The emphasis that actually came through in what we had to deliver was about the CD that contained the teaching materials, not actually the service provided of educating the students. And so something about the history with the civil engineering, the mechanical engineering, the kind of things that were delivered are the sort of subject matter of the traditional delivery contract. And it's harder to, well, it doesn't fit very well to have a contract either to deliver a service or to deliver something more nebulous like software, if you're trying to write it in the same T's and C's as to deliver a three-dimensional thing.
Yeah, we're living that nightmare right now where we're trying to deliver systems engineering as a service. And yeah, that's what we're engaged in right now. And it's this intangible thing that the folks that have asked us to do it. I mean, the document, you know, was written by one consultant, and then there's like 17 other consultants that are coming in to, and you know, deliver the project or the oversight on the project. And our part of the oversight is the systems engineering bits. And that's become so weirdly abstract and siloed. And it's very difficult to explain after the fact to the property owner, you know, what it is. What is it that you actually do on the project would be the elevator discussion. What have you done for me today, Mr. Systems Engineer, at X $100 an hour?
And my bet would be that what they actually evaluate you on is, have you delivered the such and such systems engineering product document?
Yeah, precisely. Yeah, you got it. Yeah.
And so what you do is you send some pimply kid who's a new graduate off to write each one of them without talking to each other, and you've delivered all the documents required.
Exactly.
And you say, pay me.
And where it falls apart is the intellectual part of the work wasn't done.
Yeah. Yeah, exactly. Yeah. Like the actual, I don't know, analysis of the requirements.
Yeah.
Yeah.
Okay, are there any other questions? We've got another 4 minutes for Tim. Or Tim, do you got anything you want to wrap up with?
No. It's been good discussion. Thank you for letting me turn up and talk.
So Tim, tell us, what's your next project here? You've been doing lots of different things. There's the Northern Rail stuff. There's HS2. Where are things going for you?
So we've got some overseas work, working on some freight line upgrades, some CBTC deployments for freight lines. So I look like I'm going to be rolling onto that in the near future.
Oh, that's good. Yeah.
Try to solve some problems there.
Well needed. Yeah. Okay. Let's see. To let those know, we are recording this, and therefore, when I know on our side, on the rig side, when I put out the next announcement, a link to the presentation is there, and I think the TWG does the same. So the links are there. You can see it again. You can go out to everybody, and they can watch Tim at their own leisure and do that. I also ask if we're starting to look at doing surveys, just to see, how is the speaker, what kind of ideas, what kind of things do you want to see. If you're interested in getting one of those kind of surveys, just put your email in the chat, and then we can send something out to you and see if you take your feedback. We're really looking for feedback on ideas, on our speakers, and things that we could do differently to make the experience more pleasurable.
Yeah, and just to tack on, if I could,
Yeah.
Mike, if anybody has any suggestions for, we've got another 12 months of webinars to work on, and suggested topics, focus points. So we can talk a little bit about this, I guess, during the international workshop in January. But yeah, just to maybe to start the wheels turning in people's heads, if there's something that they're very passionate about, love to hear, and if they want to present, of course, Pokey is all ears.
Hello, it's Isabel speaking. I want to ask if there is a schedule, like, do we know what's next meeting? Do we have a planning, or is it somewhere available, or how does it work, like the schedule of the next topic?
I'll blame Mike on this one because I had slides to show that at the beginning, but Mike just took it away, which is good, but
go ahead, Yogi. Show it. It was on the flyer.
I don't know why at the beginning I didn't see it. I'm sorry.
No, well, I skipped through, all those, and Mike was, already introducing Tim. So yeah, I just don't want to steal the thunder again. But but Isabel, we have to, have your email,
Well,
so I can. Let me pull it up.
Yeah, please pull it up. The short answer is I think we have Tim coming back in January.
That's
and
correct.
we've got an APTA kind of discussion in December.
Yeah, I will watch the recording. If it's in the recording, I apologize. I don't know why. I just saw the end. I don't know.
One second, right?
It's almost there.
Almost there.
It's in the flyer as well at the bottom.
Yeah, the trick is that some of us
middle.
didn't receive the flyer.
Yeah.
Yeah, that was weird.
For this time. That's why. There is, yeah. Oh, but here we go.
There you go.
If you
Okay.
can see it, yeah. So next month we have, I believe Dale will present APTA Systems Engineering Standards update, or Dale, or maybe a designee from you, and we have Tim back, to start the new year off, and then February we are talking about having one webinar on contracts. So yeah, because and it is a discussion, right before a few minutes ago.
How do we communicate topics that we would like to be discussed? What's the protocol?
Well, just send us an email, any one of us, Mike,
Yeah.
myself, Dennis, Hokey, anybody that's on the steering committee.
Like Dale, I can send an email to Dale, right?
Yeah.
Of course, yeah. Dale runs the show, so yeah.
Anybody but me, yeah.
Now,
but yeah, we'll be buried within there was 1,000 emails a day. So, and he has
Who is the best contact to send the email to?
I'll say probably send it to me. Yeah, I can coordinate. Yeah.
Okay.
Yes. Let me. Well, where's the chat? Let me put my email in here. But let's see. There you go. 1 second. Typing right now. Not fast enough. All right. Here we go. Yep. All webinars go. You know, ideas. Yeah, you can just shoot me an email, and there are 11 more topics for next year to so we can start early and give me an easier time.
Oh, I guess a quick public service announcement too for INCOSE. I don't have the exact date memorized, but maybe when you guys do. I think the extension for IS submissions is the 26th. Yeah. It went from I think the 11th to the 26th. So if you still have a few days to write your paper.
Well, you can write it on Thanksgiving Day in the US. It was 25th, and yeah.
Just check if it was the 21st.
Oh,
That's a Sunday. Well,
maybe
I'll have a look at my emails and see if I can find it.
Oh, you said the twice. I got pushed back.
Yeah, we could be wrong.
20 something.
Yeah,
we can double check. Yeah.
that might have been more of a challenge.
now, just as a bit of I guess, clarification, this is the list of the webinars that are coming into the TWG and to presenting those. We also, on the rig side, have a series of people I've lined up for different webinars. It doesn't have to be on the same date. In fact, we'll probably do dates that are different, so we don't conflict with these. But that's also another source of good railway transportation, systems engineering webinars on a variety of subjects. Most of the subjects are in the UK, but they are very applicable to other places. So we have that as well.
All right. Any more announcements? I'm going to switch to here.
Nope.
We do it in reverse order this time. So yeah, and then the last public service announcement is the YouTube channel that we have. We passed 100 subscribers, so we got our own link. INCOSE Transportation Working Group, you name it. So yeah, we'll put the recording on YouTube in a few days' time, and depending on how fast the cloud we can get it. But,
I've just checked the INCOSE website. The paper submission date was extended to November 21st.
Oh, okay. So
2 days time, 3 days.
Yeah, so don't spend your Thanksgiving doing it and then not find something.
Well, spend your weekend doing it. This weekend. Yeah.
This is Sunday. Before Thanksgiving.
Or you'd be way ahead for 2023.
I have a funny story about one like that. A group
I want to thank everybody for attending, and a little hand to Tim. Good job. Provided lots of good discussion and some clear insights on where things are and where they could be.
Thank you very much.
Thank you.
So have a good evening or good afternoon.
Thank you.
Thanks very much.
Thank you.
Good evening.
Bye.
Bye.